Let's take a look at an example using the binomial theorem. We're asked to expand this binomial. Of course, we're going to be using the binomial theorem when we're working with binomials. Two terms to a power, that's a binomial. The first thing I do is I realize we can use Pascal's triangle. I write my Pascal triangle of the coefficients 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This is a plus b to the 0, a plus b to the 1, a plus b to the 2, a plus b to the 3, which is what I want. In Pascal's triangle, I say let a equal 4x and let b equal negative 3. So I have a plus b to the third, and I know that's 1, 3, 3, 1, a3, a2, a1, a0, b0, b1, b2, b3. Well, now all I have to do is replace a with 4x and b with negative 3. You see, every time I had a, I wrote 4x, and every time I had b, I wrote negative 3. I follow my rules of algebra, and ultimately I get 64x to the third minus 144x squared plus 108x minus 27. I can do this problem using Pascal's triangle. Could we have done this same example using the binomial theorem? We sure could have. If we're talking to the third power, it will be 3c0, 3c1, 3c2, 3c3. And then I can directly plug, if this is a and this is b, AB, 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 and it's simply 3 minus 0 is 3, and then the 0 goes there. 3 minus 1 is 2, and then the 1 goes there. 3 minus 2 is 1, and then the 2 goes there. 3 minus 3 is 0, and then the 3 goes there. Ultimately, we get the same answer. Don't forget that 3c2 is 3 factorial divided by 3 minus 2 factorial times 2 factorial, and you must subtract first before you take the factorial. And we know that 1 factorial is 1 and 0 factorial is also 1. In example 2, this is where our general term with the binomial theorem comes into play. Find the fifth term of the expansion x plus 2 over x to the 10th power. The key concept here is that the fifth term, or t5, will be 10c4. The fifth term will have a 4 there. We can look and consider the coefficients of each of the numbers in this expansion. It will be 10c0, 10c1, 10c2, 10c3, 10c4, giving us our first, second, third, fourth, and fifth term. So we can see here as well that our fifth term will be 10c4. Well, it will be 10c4, our first term, x to the 10 minus 4, and our second term, 2 over x to the whatever's there goes there. 10c4 is 210, x to the 6th, and then remember this is 2 to the 4th over x to the 4th, which ultimately simplifies to 3,360 x squared. In our third example of the binomial theorem, we're asked to find the coefficient of x to the 12th in the expansion of the binomial x squared minus 2 to the 8th power. So the way I started this was using the binomial theorem. I know it's 8c0, 8c1, 8c2, and I have my first term, x squared to the 8th, that's 8 minus 0, negative 2, which is my second term, to whatever's there goes there. And then 8c1, x squared to that 8 minus 1 is 7, and then 1 goes there as well. 8c2, x squared to the 6th, and then 2 goes as the exponent of negative 2. Well, here I see x squared to the 6 is 6 times 2 is 12, so I know it's my third term. When I write my third term down here, I can't just do 8c2 to find my coefficient because I have negative 2 squared here, which is 4. 8c2 is 23 times the 4 gives me 112, so ultimately 112 is the coefficient of the x to the 12th term.